Welcome all. This is an introduction to ethical hacking course. This one will be significantly more advanced as opposed to that one. That being said, the requirements for this one will be also significantly different. But before we continue any further, let me just go over a few things. First of all, my throat is getting dry because this is like the 5th time that I'm attempting this, and certain very rude people keep interfering. But anyway, there are a few considerations to make here. So first one is, what can you expect to learn from this course? Well, you can expect to, I will show you basically how you can compromise systems, monitor the traffic in the air, fight against encryption, what you can do with encrypted traffic, how you can attempt to decrypt it. Some of it you will be able to decrypt. I will show you various methods of positioning like listening posts in the middle and how to take off certain layers of encryption and extract the useful information from the data which is out there in the air. I will show you various methods how to compromise systems in general, like PCs, servers, phones, smartphones that is. And we also might play around a little bit with the GSM network and see some of the vulnerabilities there. That's a 2G network, so you have 2G, 3G, and 4G. 2G is the GSM, and 4G is the LTE or LET, one of the two. I keep messing around. I keep forgetting the order of the letters for some strange reason. Anyway, I will most likely at a certain point in time also talk a little bit about social engineering, and you will see the practical aspects of that as well. But there are two primary considerations that you should make when taking this course. So moral side of things, and legal considerations. So just because you will be able to do something, and I will teach you how to do some serious damage with the knowledge that you get, you will be able to do some serious damage, but that doesn't mean that you should, and there really is no need for you to do so. But just think about it. You don't want anybody messing with your stuff, so don't mess with anybody else's stuff. There really is no real or justified reason for you to do it. Legal aspects, legal considerations. In most countries, it is illegal to mess around with systems you don't have permission to mess around, or systems that you yourself do not own. Just to give you a stupid example, it's illegal to mess around with your neighbor's Wi-Fi. It's illegal to connect to it without that person's permission who owns it. So even these small, I would say negligible things are taken into consideration by law. Not to speak of breaking into the servers or taking information from the phones, personal information from the phones and other kinds. That's all covered as well. So you can get into a lot of trouble if you misuse the knowledge. I will give you a lot of knowledge here. I will show you how to do various things. Please do not abuse the knowledge. Use the knowledge, do not abuse it. Okay, that being said, let's go over to the other side. Aside from the cute puppy up there that my friend drew, sitting over there and smiling for some strange reason, doesn't want to come on camera, God knows why. You will have software and hardware requirements for this course. So those are the two, well, you have 3 requirements. One is software, one is hardware, and the third one is your current knowledge, your current amount of knowledge, so to say. Let's begin with the operating systems. So Windows and OS X are completely incompatible for our purpose. On OS X, you lack a large amount of tools and you lack hardware compatibility in the first place. Even though you have a Unix, Linux-like shell, it's really not a system that you want to use for this purpose. Windows as well, Windows is even worse, and you don't have the degree of anonymity while using Windows is not really that good. With Linux, it's open source. You know all the traffic that's coming out and that's going in. You can monitor it, you know exactly what it is. All of it can be decrypted. With Windows, you have, I've noticed a lot of unauthorized communication from my machines, and it's closed source. We don't know what's going on in the background, don't know the source code. And you might say, well, I know the source code of Linux, but I'm not a developer. I have no idea what it means. It doesn't matter. A lot of other people know what it means. A lot of other people who make it, somebody would say something out there on the forums if there was something funny going on there. I don't know what's going on with Windows under the hood, and I don't know what's going on with OS X under the hood, and therefore I generally don't like using them for anything unless I am practically forced to do so. My primary operating system that I use on my daily basis for productivity work, for pen testing and development is Linux, and it has the largest, and it has practically the best tools for development and for pen testing. It doesn't matter which distribution you are using, you should be able to install pretty much all the tools on all the distributions out there. Anyway, you will need a machine where you will have Linux installed. So you will need Linux as an operating system installed. I will tell you which distro to choose, I will make a suggestion, and I will show you how to install it. Now, to answer your questions in advance, yes, you can have a virtual machine on Windows or OS X. Yes, you can have a bootable USB with persistent storage. And yes, you can have dual boot on Windows and OS X. All these three setups are, first of all, you're going to encounter a lot of problems with dual boot with both Windows and especially OS X. Linux dual booting with OS X and Windows is a huge problem, especially with the UEFI BIOS. Some of you might argue and say, well, it's not, I've succeeded in doing it. Yes, I've succeeded in doing it. It works, but it's a hassle to get it to work, or at least it was a hassle for me. The process is buggy. I can encounter a lot of problems, and a lot of your problems I cannot replicate. I do not know how to solve. I can't replicate them, therefore I don't know how to solve them, because the dual boot behaves differently on different machines with different BIOSes. On different motherboards, that is. So, have a machine which has Linux installed as a single operating system. All these other optional setups, like dual boot, live USB, virtual machines, I'll go ahead and create these videos for you, and I'll post them on YouTube as optional setups. But that's not the setup that I will be using. That's just something that I will post there for you so you can have a look. They will not be a part of this course at all. They will be on YouTube. They will be completely free. No need to register or anything like that. You can just, if you want to have that kind of a setup, you can go and have a look at it, but I make no guarantees there. Okay, so in terms of hardware, first thing that you need to consider is driver compatibility. Driver compatibility has been an issue for a very long time with Linux, but lately it hasn't been a problem almost at all, because Linux nowadays supports pretty much most of the devices out there without any problems with open source drivers, and open source drivers, yeah, they tend to work like really, really, really well with most devices out there. There's still hiccups here and there, but it works. However, you will need to make sure that your system that you are using in terms of hardware components is compatible with the Linux kernel. You do this by basically getting the list of components of your PC and just typing in on the net, like wireless card, model number, drivers for Linux. And it's going to tell you, yes, they do exist, or no, they do not exist. And you type in, like, graphic card, this graphic card's drivers for Linux. Yes, they do exist, or they do not exist. So those are some of the checkups that you need to make. In general, if the drivers exist for, if you have drivers in one distribution and if they're open source, you're going to have them pretty much all the distributions without any problems. Next up is really important. So router access. You will need access to your home router. You will need to be able to access it. A lot of ISPs these days, they tend to block the user access to the home routers. I don't know why they do this, most likely because they don't want a ton of people messing around with the configuration on the routers, and they don't know what they're doing, so they mess things up and then they call support, and it takes away valuable time and effort, but it costs them money, so they just lock the routers. But if you don't have access to your router, what you can do is just give them a call or write an email asking that you would like to have a permission that you would like them to unlock the router, and they will tell you, okay, but you can do this at your own risk. Most likely, if you mess something up, they will charge you some small amount to restore the original configuration. But you can basically back your router up. Once they unlock it, you can just create a backup file, and you can use that as a restore point in case you do not know how to restore internet connection in your house. However, you will need access to your router because we're going to be configuring, we're going to be opening up this machine to the outside world, so it will be accessible from outside world. This will be necessary for certain setups. I will show you how to configure the router, and what you need to do is pretty much the same on every router. However, the interfaces on the routers will vary, but it's quite simple. It's quite simple. There isn't that much to it. Wireless cards. This is also something that you need to keep in mind. They need to be not only compatible with Linux, but they need to be compatible with AirCrack and Reaver. So AirCrack-NG and Reaver. Some wireless cards function well, others do not. You can look it up on the net, which ones do and which ones do not. In the final account of things, you can just go ahead and use the one that you have and see how it works out. Chances are that it will work, but again, some information, that's the sort of information that you look up on the net. You see, first of all, you establish which chipset does your wireless card uses. You can do this by typing in the model of your wireless card on the manufacturer's website, and the manufacturer will have the chipset listed there. Then you check whether that chipset has compatible drivers for Linux and whether that chipset is supported by Reaver and AirCrack-NG. All this information is listed on the sites. So you just use your favorite search engine, and I assure you, you'll find these results without bigger difficulties. If you're failed by some crazy chance to do so, just go with the flow and see what happens. See if it works out or if it doesn't. The CPU. Now, the CPU that you have should support virtualization options. That means for Intel, you will need VT-D, and for AMD, you will need AMD-VI. These are the flags which tell you that the processor is capable of virtualization. That's the simplest explanation I can give in that regard. Make sure that it would be nice if your CPU supported virtualization so that you can do everything that I do as well. How do you check this? Well, you go onto the manufacturer's website again and you see whether it supports it or not. You can even ask the manufacturer with an email, hey, does it support virtualization or not? Just give them a call, and ask them, quite literally, just give them the model number and they'll be able to tell it to you, yes or no, without any problems really. Now, RAM. It would be good if this machine, where Linux will be installed, will have at least 4 gigs of RAM. Linux doesn't necessarily require 4 gigs. It's going to run on less than 2 gigs without bigger difficulties. It's not RAM hungry like Windows 10 OS X are, but it would be good if you had more than 4. Why more than 4? For smoother operations of virtual machines, because we're going to have some of them that we're going to set up there and that we will use as our own small virtual servers, as our own pocket environments where we shall conduct our research and the service which we will use in order to go through the course. We'll build our own environments where we will perform whatever it is that we need to do. USB. Have a USB lying around. Some USB. It need not be a big USB. It need not be a 3.0 USB or anything like that. Pretty much any USB stick will do. What you will need it for? Well, one of the basic things that we might need it for is, hey, I can show you how you can make a cryptographic key, how you can convert your USB into a crypto key. When you plug your USB into a laptop, it basically unencrypts your drives, and it unlocks your PC. And then you can add another layer of security on top of that, and it can request for a password confirmation as well. So that's really good security for you right there. In addition to all of this, I will also show you how to monitor traffic, how to protect yourselves, how to secure your environment, how to figure out what is going on in the network, where to post listening, where to listen for the network traffic, how to figure out what is going on, and such things. And in addition to all of this, my final thing that I would like to say here, state here, is the disclaimer. I am not in any way responsible for what you do with the knowledge that I give you. I'm giving you this knowledge in good faith. This knowledge is presented here in good faith that you will use it properly and that you will not abuse it in any way. As all of this is for educational purposes so that you would gain knowledge, not so that you could mess around with your neighbor's Wi-Fi. I mean, just don't do that. It's quite stupid. You have nothing to gain and you can get into a lot of trouble for no reason of whatsoever. So that's it. I'm gonna go ahead and bid you all farewell and wish you a ton load of luck with this course, and I hope that we have a lot of fun as we go through all of these things.